What's up, Geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to start lesson 3.8, but this is more of an intro to 3.8. So if you were working on just trying to know the differences of parallel and perpendicular lines, go ahead and look at day 2, but day 1 really helps get you started because we're going to talk about everything that you talked about last year in Algebra 1 as far as slope and slope-intercept form. We're going to review the types of slope, how to find slope from a graph and 2 points, review slope-intercept form, and how to write equations in slope-intercept form, and then finish up with point-slope form and rewriting equations from point-slope form into slope-intercept form. So first thing we're going to look at is the 4 types of slope. So we have, first one is positive slope because it's increasing from left to right. The second slope we see is negative because it's decreasing from left to right. The third slope we see is 0. If you want to think about like incline on a treadmill, that's one way you can remember this one. It's just a flat horizontal line. And then the vertical line is considered an undefined slope. And we talk about you can't run on a treadmill if the treadmill is vertical. Go ahead and make sure you have this copied down, and when you're ready, let's go ahead and try to find some slope. So we can find slope 2 ways. The first way is the easiest way, I think, and all you'd have to do for your slope on a graph is to do your rise over run. So that would be, and you're going to do that from left to right. So what would I do is I'd start with my left point, point A, and I would go to point B. So my rise would be 1, 2, 3, 4. I'll write rise here. And my run would be 1, 2, 3, 4, 5. So if I'm thinking about putting this in rise over run form, I'm going to write 4 over 5, and it's in simplest form, so I'd leave it there. If I have 2 points, I'm going to use my slope formula of y2 minus y1 over x2 minus x1. Another way you could use 2 points is just think about how is y changing over how is x changing. So let's look at that example here. In points A, B, I have x1, y1, and in points B, I can say that's x2, y2. So to do y2 minus y1, I'm going to do negative 1 minus 5 over x2 minus x1, 6 minus negative 2. Being careful of my double negatives there. Negative 1 minus 5 is negative 6, and 6 minus negative 2 is actually equal to 8. And then I would simplify this as negative 3/4 for my slope, okay? You can also look at your changes in y's. How did negative 1 jump to 5? It jumped up by positive 6. And how did 6 change to negative 2? It went down by negative 8, so you still get a positive 6, negative 8, which would still make your whole entire thing negative. Now we're going to move on to slope-intercept form. So in the format of y is equal to mx plus b, m always represents your slope, so this is where your slope would go, right next to the letter x, and b is going to be your y-intercept. So b is always at the end for your y-intercept. Y and x are just there as kind of placeholders so that you know y is equal to, here I'm about to show you where my slope and y-intercepts are. Slope is always connected to the x. So if I were to write the equation of a line with slope of negative 2/5 and a y-intercept of 7, I would just plug those into my things here, okay? So my equation would be this: y is equal to, slope first, negative 2/5 x, and then a positive 7, so I'd write plus 7, okay? The next one we see is not in slope-intercept form yet. I need to solve for y to get my equation in slope-intercept form. So one way I'm going to do that is I'm going to add 5x to both sides first. So I would get 6y is equal to 5x plus 30. Again, I'm pushing that x in front so it can be in slope-intercept form. And then my next step here is to get y by itself, I'm going to divide everything by 6. So that's just going to make it be y is equal to 5 over 6x plus 5. Okay? Next up is we can also write slope-intercept form from a graph. So we're going to look for both of our things. We're going to look for slope, and we're going to look for our y-intercept. Usually y-intercept is the easiest one to find because that is where it's intercepting the y-axis. So my y-intercept is at +1, and my slope, remember, is rise over run from left to right. So to find my slope, I'll start here. This is my left point, and it looks like I'm rising 1, 2, 3. So that's a -3, and I'm running 1. So my slope was -3/1, which just reduces to -3. So in slope-intercept form, I'd write y is equal to -3x plus 1. Okay? Moving right along, next page of notes, we have point-slope form. This is the one that you might not be as familiar with, but we're still going to write it down just because it's easier to use these things when we're given a point and slope. So y minus y1 is equal to m parentheses x minus x1, okay? This is when you would use if you have slope and a set of points, the line goes through. So you can see that in both of these examples. Write slope-intercept form of the equation of the line going through the point for -3 and the slope of -2. So that means I'm given my m and my x1 and my y1. So I'm going to plug those things into point-slope form. Here we go. Y minus y1 would be y minus -3. Eventually we'll just change that to y plus 3. And then is equal to m, -2, parentheses, x minus x1, so x minus 4. Okay, I already changed my y minus -3 to y plus 3, and then what I'm going to do here is distribute that -2 to the x, so -2x, and the 4, which would be plus 8. And then to get y by itself, because I want this in slope-intercept form, I'm going to subtract 3 from both sides. So my slope-intercept form going through the point for -3 is y is equal to -2x plus 5. So that means if I graphed it, it would go through the point for -3. Write the slope-intercept form of the equation of the line going through these points, -8, 5. That is my x1, y1, and my 5/4 is my slope, which is m. So y minus y1, that'd be y minus 5, is equal to m 5/4, parentheses, x minus -8. Okay, something to keep in mind here, x minus -8, I can easily just change that to x plus 8. So now I'm ready to start. Don't freak out about distributing a fraction here. This is 5/4 x, and then 5/4 times 8 is like saying I'm going to multiply 8 by 5, which is 40, and then divide by 4. So that's going to give me a positive 10. So now I have this, y minus 5 is equal to 5/4 x plus 10. I'm going to add 5 to both sides to get y by itself, because again, want that in slope-intercept form. Y is equal to 5/4 x plus 15. Okay. The last two examples we have, now we don't have slope, but we do have our 2 points, and we have the line that the 2 points are going through. So what I would recommend here is first find slope, and you could do that using the change in y over the change in x, which is your y2 minus y1 over x2 minus x1, and then use slope and one pair of coordinates in point slope form, or PSF. So up here when we talked about point slope form, PSF. Cool? All right, here we go. So step 1, we'll label that right here. Find our slope. I'm going to say -3, 5 is x1, y1, and then -2, 4 is x2, y2. So I'm going to do y2 minus y1, which is 4 minus 5, over x2 minus x1, -2 minus -3. Be cautious of your double negatives. 4 minus 5 is -1, and 2 minus -3 actually means, -2 plus 3, which is equal to positive 1. So my slope is equal to -1. Okay, that was step 1. Step 2 says, now that I have my slope, go ahead and use that slope in your point slope form, so y minus y1 is equal to m parentheses x minus x1, and plug it in with one of the points. Since I labeled this one x1, y1, let's just go ahead and use it. So my y1 is 5, so y minus 5 is equal to m, negative 1, and then x minus x1 would be x minus negative 3, but keep in mind, double negative actually changes to plus positive. Distribute that negative 1x minus 3, and then over here I have y minus 5. To get y by itself, we're going to add 5 to both sides. So I'm going to get y is equal to negative 1x, or negative x, plus 2. Okay? See if you can try this one on your own. So go ahead and pause the video. This one's very interesting. So when you get stuck or when you're ready to check it, go ahead and click play. All right, step 1, find my slope. So I'm going to go and label x1, y1, x2, y2. And y2 minus y1 is 17 minus negative 5, and x2 minus x1 is 4 minus 4. 17 minus negative 5 is 22, and 4 minus 4 is 0. And we're going to get something called undefined. Okay? So the question now becomes, I can't put m is equal to 0. M is not equal to 0 because 22 divided by 0 is giving you undefined, which means you want to maybe think about what does the graph look like when I have undefined or even plotting your points. So let's just pretend I have 4, negative 5, maybe that's here, and then 4, positive 17's here. Okay, this line is a vertical line because it's undefined, right? So when we talk about vertical lines, we won't necessarily have y is equal to mx plus b, because y is equal to mx plus b creates a positive, negative, or 0 slope. Instead, we're going to have x just being equal to 4. How do I know that? Great question. I'd love to tell you. Both of my x values are 4, so anytime I have an x matching a number, that is what's going to be my line. X is equal to 4. Okay? So you can't write that one in point slope form or slope intercept form because of that undefined slope, and we prove that by just showing our picture of it. That's all the time we had for today. So just reviewing linear equations. Thanks so much for tuning in. Hopefully this gives you a little bit of a push to get started on 3.8 slope and equations of lines, day 2. Have a great day. Bye.